In this video, we're going to go through 8 problems talking about transformations of some different parent functions. See if you can do these problems on your own, and we'll go through them together. You might want to take a screenshot or write these problems down so that you can attempt them on your own. And keep in mind that there's more than one correct way to do some of these transformations. However, there are ways that you may think that you can do the transformations which will give you the incorrect final graph. So try to be real careful with the order of transformations. Also try to identify what exactly is the parent function and then go ahead and list the order of transformations. First thing we'd like to do here before we dive into the problems is just kind of review a little bit about the different rules or ways of looking at what's happening to a parent function. So the first thing that we want to take a look at here is this one here, f of x plus k. Now keep in mind f of x is like our parent function, and then when you add k to that parent function, what it does, if k is positive, is going to translate or slide or shift that graph up by k. Whereas if k is negative, it's going to then translate or shift or move that graph down by whatever k is. So if it was -3, it would shift down 3. If it was +3, it would shift up 3. Now if we go down to the second rule here, you can see a is being multiplied by the function. So you're taking that function, you're multiplying it by some value a. If a is greater than 1, like 1.5, 2, 3, 4, then what it does is it stretches by whatever that a value is, by that factor. So if it's 2, it would basically stretch it in the y direction or the vertical direction by a factor of 2. Now if a was between 0 and 1, like a half for example, then we say it's a vertical shrink by a factor of whatever a is. And then lastly, if a is a negative value, then what it does is it reflects the graph over the x-axis. So it's just going to take that whole graph and do the mirror image or reflect it over the x-axis. Now let's jump down to this last one before we get to this third one here. So the last one, f of x minus h, notice that this x minus h, it's in parentheses, it's grouped with the x. So when it's grouped with the x, we know that it's going to move the graph in the x direction, the horizontal direction, and we say that it's a horizontal shift by whatever h is. Now keep in mind, if it's in parentheses and it's like x minus 3, it will actually have the opposite effect. The minus 3, people think left 3, but no, it's actually going to shift it to the right 3. If it's x plus 3, it's going to shift it to the left 3. So it actually appears to be a little bit opposite from the sign. But if you see here x minus h, if it's x minus 3, it's actually shifting to the right positive 3, see? And then the last one that sometimes students struggle with is where it's f of a times x, okay? And you can see again that a value is grouped with the x, okay? It's in parentheses, it's grouped with the x. And what happens is if a is greater than 1, what it does is actually a horizontal shrink by 1 divided by a. So for example, if this was f of 2x, it would actually multiply all the x values by 1/2, and that's what shrinks it horizontally in the x direction. Now, if the a value is between 0 and 1, then it's going to be a horizontal stretch by a factor of 1 over a. Again, the reciprocal. So if a was like 1/2, like if this is 1/2 x, grouped in parentheses like that, then it's actually going to be 1 divided by 1/2, which is actually 2. So it multiplies the x values by 2 and stretches it horizontally by a factor of 2. And then lastly, if a is a negative, okay, and again, grouped with the x, then it's going to reflect it over the y-axis. It's basically making all the x values the opposite sign, which reflects it over the y-axis. Okay, so let's dive into the problems now. So this first one, number 1, y equals 2 times the absolute value of x plus 1. So the parent function here is y equals the absolute value of x, right? And we know this isn't really going to be going into the graphing so much in this video. I'll put a link to another video if you want, talking about how to actually graph these. But this is basically a V-shaped graph, that absolute value graph. And when you're talking about the order of transformations here, what's going to happen is we're going to be multiplying the y values by 2. It's a vertical stretch by a factor of 2, followed by a translation up 1. So in this case, there was really only one way to do this order of transformations. vertical stretch by a factor of 2, which if you're interested in the graph, it's going to basically make this graph a little bit steeper because you're stretching it or pulling it in the y direction. You're multiplying all those y values by 2, okay? And then the plus 1 would then on the next step would take that graph and would shift it up 1 unit, and it would look something like that. So we'll talk about the graphing in another video, but for now let's focus on the parent function and then the order of transformations, which is oftentimes confusing for students. Okay, for number 2 now, what did you get for the parent function? Did you get y equals x squared? So that's your core function, that's your basic function that you're working with. Again, keep in mind, x squared is a quadratic function and it's a parabola shape when you graph it. But as far as the order of transformations here, notice we have a few things going on here. We've got this negative, we've got this 1/3, and we've got this -4. So what do you do first, second, third, right? Well, the 1/3 that comes in front, we could say that's going to be a vertical shrink by a factor of 1/3. So basically that's going to be squeezing it towards the x-axis. Okay, so it's making all the y values 1/3 as high. If you wanted to kind of just visualize it in a rough way here, I could kind of show you it would be a little bit wider, and that's because you're squeezing it towards the x-axis, making all the y's 1/3 the height. But then what comes after that vertical shrink, let's see, well, we can see that we have this negative here, and that negative is going to make all the y values the opposite, which is going to then take that graph and reflect it over the x-axis. So we're going to say reflect over the x-axis. And then the last step here is this -4, and that -4 is going to shift the graph or translate the graph down 4 units. And so that would look something like the graph that we just did previously, and then it's going to be going down 4. Now you can see this isn't on graph paper, so it's not perfect, it's not exact, so don't hold me to that. But the main thing we're focusing on is what happens first, second, third. Now, remember how I said there's more than one way to do these? Well, you could have also said that the vertical shrink came after the reflection over the x-axis, so you could have interchanged those. However, you wouldn't want to shift down 4 first and then reflect over the x-axis. That would not be the same final graph. So it's important that you pay attention to the order of transformations. I oftentimes like to think about working from the inside out, and that's sometimes is a helpful way of thinking about it. And we're going to see as we go into some more challenging problems how to approach that. But in this case, it was a vertical shrink and then reflect over the x-axis. Either one of those you could do first and second, and then the last one shifting down 4. Okay, so for number 3 now, what did you get for the parent function? Did you get y equals square root of x? So just keep in mind when you graph the square root function, it looks something like that. Y equals square root of x, that's the basic graph. But now remember how we were talking about, okay, order of transformations. We've got a couple things going on here. I like to start from the inside and work my way out. That's how I like to think about it. So what I'm going to do here is I'm going to say, okay, the minus x minus 1, that's grouped with the x, okay? So when it's grouped with the x like that, it's going to shift the graph in the x direction, left and right, right? But when it's grouped with the x like that, it has the opposite effect. Okay, minus 1 actually is going to shift it to the right one, okay, like that. And if it was plus 1, it would shift it to the left one. So for this one, the first step here we could say is that you're shifting, shift right 1. Okay, now what about this 5 here in front? Well, the 5 is going to be a vertical stretch, okay, by a factor of 5. Okay, so when I say by a factor of 5, it means you're multiplying all the y values by 5. And what that does, in effect, is basically like, see how this is 0? Well, 0 times 5 is still 0, so it's going to stay right where it's at. See this point right here where it's like 1? Well, 1 times 5 is 5, so it's going to now be way up here. So what's going to happen is the graph's going to basically be pulled away from the x-axis because you're vertically stretching it by a factor of 5 or multiplying all those y coordinates by 5. Now, in this particular problem, you can do the vertical stretch by 5 first and then shift right 1, okay, or the other way around. So in this case, you could do it either way. You're still going to get the final same graph, but for me, I oftentimes like to think just working from the inside out just to kind of just kind of stay consistent. But this one, you're going to get the same graph either way, whether you do the shift right one and then vertical stretch by a factor of 5 or vice versa. Okay, so for number 4, what did you get for the parent function on this one? Did you get y equals x cubed? So that's your core function. You can kind of see that if you were to eliminate some of these extra numbers here, you can see that's your core equation that you're dealing with. But then if we follow that process that I mentioned earlier about basically working from the inside out, we can see that we've got this 2 here grouped with the x. So what does that 2 do when it's grouped with the x like that? Well, we said that it has the opposite of effect, and we know that it's multiplied by the x, which means that it's going to actually be a horizontal stretch or shrink. But because it's multiplied by the x like that, we know that it's going to be a horizontal stretch or shrink, but it's going to be by the reciprocal by 1/2. So here I'm going to say horizontal shrink by a factor of 1/2. Okay. Now the next step here would be the 1/9. So the 1/9 is going to be a vertical shrink by a factor of 1/9. So that's going to basically squeeze it towards the x-axis because all the y values are 1/9 as much. And the last step here is this +7, which is going to be a shift or a translation up 7. Now, if we want to graph it, just to do a rough graph, not an exact graph here, we'll take our parent function, y equals x cubed, which looks something like this. The 2x we said is actually going to be a shrink, so you're squeezing it, okay, or multiplying all the x values by 1/2. So what that's going to do is going to basically take this point here and it's going to put it right here. It's going to take this point here, it's going to put it right here. The point that's at the origin, when you multiply 0 times 1/2, it's still 0. So what you're going to get is you're going to get a graph like that that's been squeezed towards the y-axis. Now when you do the 1/9 in front here, this 1/9, you can see that's a vertical shrink by a factor of 1/9. So it's going to take this graph now, the second one here we did, and it's going to squeeze it towards the x-axis. Okay, basically all these coordinates, these y values are going to be 1/9 as much. And so what it's going to do is basically squeeze it or push it towards that x-axis. Then the last step is going to then shift it up 7. Okay, now like I said originally, there's more than one way to do some of these problems. So we could switch this horizontal shrink and this vertical shrink. We will still get the same answer. But if you were to shift up 7 first and then try to do any of these other steps, you're going to get a different final graph. So you can do horizontal shrink, vertical shrink, and then shift up 7, or you could do the vertical shrink, horizontal shrink, and then shift up 7. You've got a couple different options on that one. Okay, number 5. So this one, what did you get for the parent function on this one? Well, it looks like we have y equals the cube root of x. That's our core function. And just remember the cube root function, it kind of looks something like this. Again, I'm not doing this on graph paper, so it's not exact. But here we're focusing on the transformations. So again, like I like to do it, I like to basically identify that parent function. Then I like to kind of start on the inside. See, to me, this is on the inside, and work my way out. One thing you have to be careful of, though, on these little bit more complicated problems is that when you're working from the inside out, you actually want to think about the reverse of the PEMDAS or order of operations, okay? And you can see here, normally you would think, oh, 1/2 times x, that's multiplication, right? And then the +4, that's addition. And you'd say, normally I do multiplication first and then addition second when you're simplifying, right? But when we're talking about the order of transformations here, we're going to actually do the reverse. We're going to say the +4 is actually going to shift the graph left 4. And remember, it looks like +4, but when it's grouped with the x like that underneath that cube root, it's going to have the opposite effect. It's actually going to shift the graph left 4. The 1/2 now, the 1/2 x, again, that's grouped with the x, it's multiplied by the x, it's going to have the reciprocal effect. So it's actually going to be a horizontal stretch by a factor of 2, not 1/2, but 2. It's the reciprocal. And then working our way out a little bit further, we've got this 3, and we can see that the 3 is going to be a vertical stretch by a factor of 3. Okay, so it's going to multiply all the y values by 3, and then this negative is going to reflect it over the x-axis. So reflect over the x-axis. Now, sometimes, and let's just do the last step, and the last step then is this plus 2, which is going to shift the graph up 2 units. Now, just another way to look at this, sometimes students will ask, they'll say, well, how do you know whether it's having the opposite effect or the same effect, right? So let's talk a little bit about that for just a quick second. So what I like to think of again is when it's grouped with the x, so it's kind of like, you know, group either in parentheses and absolute values underneath the square root or a cube root, you know, it's grouped with the x, it has the opposite effect, opposite effect. And what's interesting, when it's grouped with the x like that, it's affecting the x values, the horizontal direction, okay? So if you can kind of remember that group with the x affects the x coordinates, the x values, the horizontal direction, and it has the opposite effect. Now if it's not grouped, like see how this -3 is not grouped with the x, it's going to affect the y values, and it's going to have the same effect. 3 is actually going to multiply by 3, not 1/3, right? So it's just same as the number 3. Same thing with the plus 2. It's going to actually shift it in the positive direction, up 2. And when it's not grouped with the x, it's affecting the y coordinates. It's going in the y direction. So a little couple pointers there. Now, as far as could we have done this in a different order? So maybe you did this and you said, you know, Mario, I didn't get the same thing you did. Is there another way that we could have possibly done it? Well, we could have. We could have done the reflection over the x-axis first and the vertical stretch by 3 first. That would be fine. And then get into the horizontal transformations. Again, you can switch these as well. You could say I'm going to do the reflection second and the stretch first, or they could do the stretch you know, vice versa. The one thing you don't want to do is you don't want to like shift it up 2 first and then start doing the other transformations. You're going to get a different final graph. So a few different ways to do this. You could either work with these vertical stretches and reflections and then do the horizontal here, or you could do the horizontal and then do these ones second. So more than one option on this one. As we get into these more complicated problems, there's going to be a few more different ways to do it. So at this point, you might be asking, Mario, why is the quantity underneath the radical have like the opposite effect from the order of operations when you're determining the order of transformations, right? Well, let's just take a look a little bit here and just kind of analyze like what's happening. So say if you had the cube root of x, right? F of x equals a cube root of x. That's this blue graph right here, okay? That's this one right here. And you can see that if we wanted to do what we call like a composition of functions, the way functions work is that whatever's in the parentheses, it goes in for the x on the right side of the equation. So wherever you see x, you're going to replace it with what's inside of the parentheses. Now, if we wanted to create a new function, let's call it g of x, and we wanted to say, well, this is going to be f of x plus 4, f of the quantity x plus 4. What's happening now is you see where this x is right here. This x is now going to be the quantity x plus 4, and that's going to go in for x on the right side of the equation. It's going to be replaced with that. So you can see g of x is now going to be equal to the cube root of x plus 4. Now, knowing what we talked about earlier, x plus 4 is going to do what? It's going to shift the graph not positive 4, but it's going to shift it actually to the left 4. So you can see this point here, 1, 1, okay, now is going to be over here at -3, 1. And sometimes students say, well, I don't get it, like plus 4, why doesn't it shift it right 4? Well, you can see like if you were to put 1 in for x right here, the square root of 1 is going to give you this y value of 1, right? Now with this new function right here, the cube root of x plus 4, if you put -3 in for x, -3 plus 4 is 1, the cube root of 1 is 1. So you can see you're getting that same output, that same y value, but what happened to your x value? It had to be 4 less, 4 smaller, right? So that's what's shifting the graph in the x-axis direction 4 units to the left. Does that make sense? Now, if you wanted to take it one step further, okay, let's say h of x now. We're going to do h of x equals g of 1/2 x. So what do? We say, well, whatever's in the parentheses, the 1/2 x, is going to go in place of x on the right. It's a substitution, so we're replacing x with 1/2 x. And that's giving us our equation here now, h of x equals the cube root of 1/2 x plus 4. But look at it here. What actually did we do first and then second? Well, you can see we actually shifted the graph left 4, right? And then we did a horizontal stretch by a factor of 2. So when you're looking underneath this parentheses here, you might say, 1/2 x plus 4. I do a horizontal stretch by 2, and then I shift left 4. But that's not actually what happened when we did this composition of functions, where we were kind of building up this function from the parent function. What we did first was we replaced x with x plus 4, which shifted the graph left 4. And then we replaced x with 1/2 x right here, and that became the 1/2 x plus 4. So really, when you're describing the order of transformations, that's why this plus 4 was a shifting left and right before we did the horizontal stretch by a factor of 2. It sounds a little bit backwards because you think, why is addition coming before multiplication? You know, that's kind of the opposite of the order of operations. But here we're talking about the order of transformations, meaning how the graph is transformed. Okay, so for number 6, what did you get for the parent function? Did you get y equals the greatest integer function? So y equals these double bars here, if you remember, it's the greatest integer function. It's sometimes called the step function. It looks like stairs, and you can see it's closed on the left, open on the right. Remember, whatever, when you're evaluating, whatever is inside of here, you're always going to round down or to the left on the number line to the nearest integer. So that's referred to as the greatest integer function. But even if you don't know that, you can still talk through the order of transformations, which we're going to do right now. And so let's see. So in this one, if I was using that technique that I like, which is to work from the inside out, I would start by working inside of these double brackets here. Okay, this greatest integer function. And I would say to myself, I know when I'm grouped with the x like that on the inside, it's the opposite of the order of operations. So what I mean by that is normally I would see this 2 is multiplied, and then I'd see this x minus 4. Okay, that's subtracted. And I also see I've got some parentheses there. So when I think of the PEMDAS, what comes first? We've got parentheses and then multiplication, right? But what we said we're going to do the opposite when it's grouped with the x like that. So we're actually going to do this multiplication first. So we're going to say that it's going to be a horizontal shrink by a factor of 1/2, meaning we're going to multiply all the x values by 1/2. That's going to squeeze it towards the y-axis because all the x coordinates are half as much, right? Then we're going to get into the x minus 4, which is going to be shifting the graph right 4 units. So it's going to pick it up basically and move it over 4 units. Remember, stretching and shrinking, you're basically like pulling on it, you're multiplying, right? But when you're shifting, you're picking it up and lifting it, kind of like a rigid transformation, they refer to it as, and then setting it down, in this case, right 4. Okay, then continuing our journey, working our way from the inside out, this 1/2 is going to be a vertical shrink by a factor of 1/2. And then lastly, working our way from the inside out, the minus 1 is going to be a translation or a shift down 1. Remember the minus 1, down 1. So again, minus 1, this is not grouped with the x. It has the same effect. Negative is down 1. If it was plus 1, it would go up 1. If it's grouped with the x, like this 4, it looks like minus 4. Normally you'd think, oh, minus 4 is to the left or negative 4, but it's grouped with that x. It has the opposite effect. It shifts right 4. So this, again, is just one way of doing this order of transformations. Another way to do it, if you didn't want to do it in the way I've listed here, is we could have done the vertical shrink first, make that number 1, right? And then we could have worked with the translations on the inside here of the double brackets, right? We could have done the horizontal shrink second, and then the shift right 3, and then finally that shift down would be 4. Again, you don't want to switch the number 2 and 3. Okay, that order is important as we listed it, but you could do the vertical shrink ahead of those, okay, or like I listed them originally here. So a couple different options. Let's go on to the next one. Okay, for number 7, what did you get for the parent function? Did you get y equals 1 over x? That's referred to as the reciprocal function. It's actually like a hyperbola that looks something like this, where you've got kind of two curves facing opposite one another like that in the first and third quadrants. That's your basic graph there. But now talking about the order of transformations, what do we do first, second, third? Well, again, I like to kind of start from the inside and work my way out. So I'm looking at that x here. I see this x plus 8, and I know that when it's grouped with the x like that, okay, it has the opposite effect. So I'm going to say that this shifts left 8. So the plus 8, it looks like it's going to, normally you would think, oh, plus 8 to the right 8 or positive 8, but it has the opposite effect when it's grouped with that x. It's going to go left 8. And then if we go, again, working our way from the inside out, we're going to look at this 3 here. And what does that 3 do? That 3 is actually like 3 times 1 over x, right? So it's going to actually multiply all the y values by 3. It's going to be a vertical stretch by a factor of 3. And then we can see there's a minus sign here, and that minus sign is multiplied by that whole quantity there. And so what that minus sign does, it's not grouped with the x, it's not on the inside, it's on the outside. It's going to actually make all the y values the opposite, which is going to reflect this graph over the x-axis. Keep in mind, if the y values here become the opposite, it's going to be on the other side of the x-axis, right? Okay, and so then now the last thing is this 2 here, and this 2 I could have just as easily put over here and made it plus 2. That would have been a little bit, I think, more intuitive, and you can certainly do that when you see a problem. If it doesn't look like, it's in the way that you're used to seeing it, you can move it to the other side like that. It's just a positive 2 or plus 2, so that's going to shift the graph or translate the graph up 2 units, right? Okay, now looking at this order of transformations, is there a way that we could have done this differently than the way that I've listed it here? Well, we could have done the vertical stretch first, okay, by a factor of 3, and then we could have even reflected it over the x-axis, and then we could have shifted it left 8, okay, and then shifted it up 2. That would be another way of doing it. Another way to do it would be to reflect it first. You could have reflected it over the x-axis and then do the stretch vertically by a factor of 3, then shift it left 8, and then shift it up 2 last. So you've got a few different options here of how you want to order these transformations. However, you do not want to do that plus 2 first and then proceed to do the other ones. You're going to get a different final graph. Okay, this last problem is kind of a it's a kitchen sink type of a problem because it has everything in this problem. I mean, almost everything. I guess we could have thrown a few more things in here, but it's got a lot. So it's kind of a challenging one. So the first thing is to start off with is basically identifying the parent function. So the parent function, you can see it's an absolute value function. That's our basic graph. Now talking about the order of transformations, again, if you want to follow the way that I kind of like to think about it, working from the inside out, okay? So when you look at it here, you say to yourself, okay, when I start on the inside, I know I want to do the opposite of that PEMDAS, or that order of operations. I've got multiplication, or by that 3. I've got the parentheses, the x plus 1 is in parentheses, and I also have this negative here as well. So let's think about this here. So normally we would do parentheses first, right? But we have this multiplication, and we said that, okay, with the PEMDAS, we're going to do it the reverse. So I'm going to do the multiplication first. So I'm going to look at that 3, and I'm going to say that this is a horizontal shrink by a factor of not 3, but 1/3. Remember, when it's grouped with the x like that, it has the reciprocal effect. Now the negative here, okay, it's grouped with that x. What that negative is going to do is it's going to make all the x values the opposite. So it's going to be a reflection over the y-axis, not the x-axis, because it's making the x values the opposite, right? And then lastly, now we've got that plus 1 in parentheses, which is going to shift the graph horizontally, because it's affecting the x coordinates, the x values, and it's going to shift it not plus 1, but to the left 1. It's the opposite, right? When it's grouped with the x like that, it's grouped inside, it's going to have the opposite effect, shifting left 1. Now working our way further out, we've got this 1/2, which again, remember, when it's not grouped with the x, it's affecting the y values, okay, up and down, the y coordinates. And so this is going to have the same effect. It's going to be a vertical shrink by a factor of 1/2. And then this negative here in front is going to make all the y values the opposite sign, which reflects the graph over the x-axis, right? If you make all the y values the opposite, they're going to be the mirror image over the x-axis. And then lastly, we've got that -8, which is going to shift the graph in the y direction, the same as this sign here, the negative, which is going to shift it down 8. Now, this problem had a lot of different transformations in it, and we could have done this in a different order than what I have listed here. There's many different combinations, so I'll leave it to maybe some input from you in the comments and other commenters as well to discuss which methods that you decided to use for this one. But just make sure you don't do that -8 shifting down 8 first. That would definitely give you a different final graph. Nice thing is you can check these by graphing them on a graphing calculator, and you can kind of walk through it and see if you're getting the same result. So great job. I'll show you another video that I did talking more about the graphs, so you can kind of get more experience with how to graph using transformations and not just describe them. And I'll put that on the screen here. And if you want to learn more about these types of problems, go ahead and check out my channel. I've got some playlists there, and I look forward to seeing you in the next video.